Do you have a part where you want to control exactly where the infill is being applied? Well, today in Follow With Me, we're going to be going through and showing you exactly how to create custom infill regions utilizing SOLIDWORKS. Hello, my name is Mark Dolinar, and I'm an applications engineer here with Hawk Ridge Systems. And today, we're actually going to be modeling inside of SOLIDWORKS custom infill pattern regions. Currently on screen, I have Eiger open with a mounting block part I plan on printing. Now this particular part is rather large, and I want to apply infill to the design in order to reduce material and reduce print time. However, I do not want to apply infill to these jaw regions in order to make sure that those regions are as strong as possible, and they give me the opportunity later on if I ever need to drill or add a hole or a bolt to them. So in order to do this, I'm actually going to jump into SOLIDWORKS and custom design my own infill regions. Let's get started. Inside of SOLIDWORKS, there's a few housekeeping tips that I will need to do in order to begin this project. The overall project itself is going to contain a number of tools and features that may seem advanced. And don't worry about this. Make sure to check out our Hawk Ridge Systems YouTube channel for more information on the tools I will be covering inside of this video. Let's go ahead and get started. I'm going to start off by saving critical features I wish to access later on in my design. Some of those features include these holes that are cut inside of our part. To save these, all I need to do is go to the rollback bar at the very bottom of the screen, left click and drag above these individual features. There is one other thing I wish to save before getting started with creating the infill pattern, and that's actually the top face of our design. To do this, I'm just going to go to the Surfaces tab, choose Offset Surface, and offset the distance by 0 millimeters. To make sure that I don't accidentally select on it later on, I'm simply going to right click on that surface and choose Hide. Now, we have the ability to get started actually creating that infill pattern. The process that we'll be using in order to create this infill pattern is first, I'm going to sketch out an individual region where I would like this infill to be placed. I'll then sketch the pattern them out individually, merge them back together as one solid body, and then add any of the auxiliary features back into place. What this is ultimately going to allow me to do is import this as an STL directly into Eiger without the need for it to slice and add its own custom infill pattern. The infill will already be placed at the part level as we begin. So let's get started. The first step in this is actually creating the region where I would like the infill pattern to be placed. I'll first begin by creating a new sketch directly on the top face of my part. Because I'm going to be using the wall thickness of this design, we'll actually be using the Offset Entities tool to define that wall thickness. For Eiger, or for a Markforged printer, the default wall thickness is about 0.8 millimeters. I'll apply this in place and always make sure to double check to make sure that it's going inwards to the part design. Because I do not want to apply infill patterns on the left-hand side where these jaws are placed, I'm actually going to finish off the sketch by adding lines in order to cancel out the regions where I would not want this infill to be applied. Now that I have my sketch complete, I'll next go to our Features tab and choose Extruded Cut. Notice here, I have multiple different contour regions, but because we have the ability to choose the region for this particular feature, all I need to do is select on the Selected Contours dialog box and choose the region I wish to cut. In this case, the right-hand side representing the infill. The final thing I'm going to do is define the end condition. To do this, we'll just go to the direction 1 and offset this by about 0.8 millimeters from the bottom surface. I'll hit OK, and we'll have the very first step in this design process complete. Now, due to the way I'm going to be drawing in these particular infill patterns, I will want to make a copy of this individual body. In order to do this, we'll go to our Insert tab, select on Features, and then move Copy. I'm going to select on the body I wish to copy, make sure Copy is turned on, and don't actually move it anywhere, keep it where it is. We will hit an error when we hit OK, asking would we like to translate or rotate, and because we're just going to use this at a later stage, click OK and continue. At this point in time, you should have 2 solid bodies and 1 surface body inside of your feature manager. I'm going to hide the second copied body to use later on. Everything's set up. The next thing to do is to actually draw out our infill pattern. For this particular example, I'm actually using a triangular infill pattern because it's actually one of the strongest infill patterns and it gives me the ability to quickly print this part. To get started with this, I'm actually going to create a brand new sketch directly on the top face to begin applying the infill pattern itself. Grabbing my line tool, I'll sketch a line in the region where I would like the first infill to be placed. I'll activate my Smart Dimension and apply any of the dimensions for this particular piece. And the offset from the wall, we're just going to go ahead and keep this as about 2 millimeters. And that's about it. We have the entire piece created for our infill pattern. But you'll notice it doesn't expand across the entire part, not just yet. For that, we're actually going to be using a combination of tools that really don't belong in 3D printing at all. But being creative, we can actually create some very unique designs with them. The first tool we're going to be using is actually going to be our rib tool. Now, the rib tool is actually found inside of the Features tab under Rib. This is a tool that's generally reserved for injection molding. However, we can actually utilize this in order to apply our initial infill directly to the part. To get started with this, I will first have to select the body because we have 2 separate bodies. We'll select the body being shown. I'll set the distance or the thickness to be 0.8, again just matching the wall thickness. And then we'll go ahead and choose the normal to sketch so that the material is actually going downwards directly into our body. When done, we'll hit OK. And because we used the rib tool, we were able to make fast work out of this particular piece. But again, this isn't expanding down through the entire part. To get this accomplished, we're actually going to pattern this from one end to the other. So let's go ahead and take a look at that. To jump into the pattern tool, I'll go to our Features tab and select on Linear Pattern. Now, in my particular example, you'll notice that the rib feature is automatically selected, and that's just because it was automatically selected from the last feature I created. If your rib feature has not been selected yet, make sure to click down on that dialog box. From here, we can now begin to set up the actual pattern itself. And for this, I actually want these to be going at diagonal angles. So I'm actually going to zoom all the way into my dimensions, and that 2 millimeter dimension we'll use for the direction of the rib. I want this rib to stop on the right hand side of the part, and in order to maintain this, we're going to actually use the up to reference command. I'll select on the reference geometry dialog box, which will highlight in green, and this is going to allow me to select on an edge, a face, or even a vertex to complete this particular operation. The next dialog box here is going to be the offset distance from that selected edge. So to match the top I'm just going to go ahead and set that to be about 2 millimeters. Finally, we will actually have to use the selected reference tool. This is going to allow us to choose on our given feature that we're patterning where the references from one pattern to the next will begin and end. And for this example, it's just going to be on the right-hand side of our edge. At this particular point in time, you'll notice that we have a good amount of ribs set up. These last two options down below are going to allow us to select the difference between the number of instances or the spacing between these instances. I usually like just modifying the number of instances itself. I'm going to set that value to be about 20. Again, if you want to have a higher infill percentage or a lower, you can add more or less. In this case, this will allow us to add all these ribs at once. From here, we can click OK, and we'll have 1/2 of that infill pattern automatically created. To create the second half, I'll now go back to our solid bodies folder, find the existing body that is shown, and hide this, and then show the other body. So at this point in time, we have a blank slate, and I'm going to do the exact same thing that I did previously. However, this is just going in the opposite direction. So again, grabbing your sketch tool, sketching out a line in the direction that you would like to have your infill be placed, applying any and all of the necessary dimensions for this particular infill, and then from here, simply applying the rib tool to this particular infill pattern. So features and rib. We'll select on the new body this time around. Make sure that the rib goes directly down into our part. Again, utilizing the same wall thickness as we did previously. Now, as we did before, I'll go ahead and jump to our linear pattern tool. For the feature, we're going to use our rib 2. And for the direction, we're going to go ahead and zoom in on that 2 millimeter value that we had previously. As we did before, we'll use the up to reference command, this green dialog box, to tell SOLIDWORKS where we would like this feature to be complete. And this is going to be this bottom vertex. And then we'll select 2 millimeters for the offset distance between this end feature and the last patterned object. And then finally, for the selected reference, we'll once again go back into our desired feature, select on the end, and we'll have our pattern established. All that's left to do is set the number of instances. I'll do the exact same amount as we did before, set that at 20, and then hit OK. So at this point in time, we now have two separate patterns going in two opposite directions. If I right-click on both bodies and hit Show, you'll now see that all these bodies are showing these individual areas where we have the infill patterns applied. Now, at this particular point in time, I actually want to merge everything back together. And to do this, we're going to have to do this in about 2 steps. You'll notice that before I have the same surface body. If I right-click on this and hit Show, this is actually going to allow me to cap off the top of my individual body. But notice, we have some distortion going on here, and that's because the ribs itself are trying to share the exact same place as that top surface. In order to fix this problem, I'm going to pre-select on that surface offset. We'll go back into the Surfaces tab, and I'm going to choose Thicken. For the thicken itself, we'll choose a value of 0.8 millimeters. And I'm going to have merge results turned off and then hit OK. You'll now notice at this point in time, we should have 3 individual solid bodies. And this gives us the perfect opportunity to use a tool like a Boolean operation, such as the combine feature inside of SOLIDWORKS. To use the combine feature, I'll go into our Insert tab, select on Features, and choose Combine. Now out of my Solid Bodies folder, I can select on each of the solid bodies, and because I want to add them all together as one, we'll just use the add operation and hit OK. The great thing about this is at this point in time, if I took a section view of this particular SOLIDWORKS body, you'll notice that the inside now has that particular custom infill region where the blocks itself on the right hand or the left hand side are still solid, but the ones on the right have this custom pattern. However, we are still missing some features, and that's okay. If I come all the way down to the very bottom of our feature manager, you'll see that we still have one feature hanging out. All that's left to do is left click and drag our rollback bar to the very bottom of our screen to see that cut extrude feature. Now this is going to make the initial cuts that we had previously, but notice if I look inside, we don't have any solid walls anymore. We now see that custom infill I just established. So there's just one more step we'll need in order to complete this model. To finish this off, I'll create one final sketch directly on the top face. And I'm actually going to go ahead and select on the outside edges of these holes that I had cut. We'll use a convert entities and then an offset entities of the exact same features that we previously had selected. And all that's left to do is do one final boss extrude from the top all the way down to the bottom of the wall thickness of our choosing. So at this point in time, if I jump back into my model and do a section view, you'll now see that I actually have the ability to have a custom infill for only the regions that I would like, leaving me with the ability and the creativity to have custom models printed of my choosing. I'd like to thank you for sticking along for this video. Again, if you guys do have any questions of any of the tools and features I've covered in this Follow Me tutorial, please make sure to check out our Hawkridge Systems YouTube channel or contact us for various training options for 3D printing or for SOLIDWORKS training.